Hello everybody, today I'd like to talk to you about stem and leaf graphs. So let's start with maybe an example like pulse rates, beats per minute. So if somebody asked you to take your pulse rate and over a minute, and then you counted how many beats you had in that minute. And if I asked a bunch of people to do that, maybe throw their answer like up on the board, it might look like this. And so I can see that there are some people with like 92 beats per minute, maybe like 59 beats per minute. And what I have now is raw, unorganized data. So I'd like to maybe organize this, and I'm going to try to use a stem and leaf. And because my values are like 50s, 60s, 70s, 80s, I think a stem and leaf would be great for this, although a stem and leaf can accommodate all kinds of discrete data. It doesn't have to be in the tens. It could be like decimal data, whatever. So this is just a nice example to start with. So notice we have raw data. It's discrete. Discrete means it's countable because we counted our pulse. We didn't measure our pulse. And now I'm going to start with the stem. So 50s, 60s, 70s, 80s, 90s, 100s. So 5, 6, 7, 8, 9, 10. That would be my stem. And then the first value that I see, the lowest value is 59. So my first leaf is a 9. The next value, well, I don't see any 60s. So some people want to put a 0 here for no 60s, but actually that would be incorrect. If you don't have a value, then don't put that leaf. So we're going to skip over the 6s, and we see a couple of 70s, so 72 and 72. And notice, because the 7's already there, I'm just giving the 1's digit. And so I'm going to continue to find all of my 70s values and move on to my 80s and so on. And then finally, I end up with 102. And so this is a great stem and leaf. I can see a couple things, but I'm also missing a couple things. First of all, I probably need a title, put this in context. So this is pulse rates. And then finally, something that people often forget, and that is a key. So 9/2 would be interpreted as 92 beats per minute, but 9/2 could mean like $9,200,000, or it could be like 0.0092 milligrams or something like that. So again, a key is really wise to put. And so notice our data is now super organized. We didn't lose any pulse rate data. We could see every individual that's answered. And we can proceed with doing SOCs, or sometimes people like to use GSOCs. So that is describe any outliers, shape, center, spread, and we can do this in a variety of ways, and we always do it within context. So when you're describing these things, you want to always say like that you're talking about pulse rates or beats per minute, so you don't want to make this like a super generic answer. And we are going to go later deeper into ways to describe shape, center, spread. I don't know if we see any outliers. 59 might be an outlier, and there is an outlier test for that. Right now it does stand alone away from the other values, so I suspect it might be an outlier. We definitely have a little gap. We don't have any pulse rates in the 60s. And then this is a somewhat triangular, definitely unimodal distribution, and we'll go on later to talk more about these things. So if you take a look and you kind of look to the side here, you see kind of like what I like to call a poor man's histogram. So you can kind of see like the bars emerging here, and you can talk about shape a little bit that way. So now what's really nice is that we can use stem and leaves for comparison as well. So we're going to use pulse rate for tennis players, and we're going to use varsity versus JV players. So let's say I have a few varsity players and a few JV players, and I have a ... because I have a few more, and I'd like to compare their pulse rates. Well, I can still use a stem and leaf, but this time I'm going to use a back-to-back stem and leaf. Yeah, great for comparison. Okay, I'm still going to have my stem be the same one that I used before, because I have pulses from like the 50s all the way to the 100 and somethings. And so I'm going to go ahead and plug in my players. And you can see 74 on the JV side is there, and 101 on the JV side is there. And we have 77 on the varsity side and 84 on the varsity side and a few others. And notice I have each side labeled. And again, I'm providing a key. So I have 9/5 equals 95 beats per minute. And again, it's read on the other side a little bit different because we always start with the stem and then we go to the leaf, which would be to the left. So it's not that you're reading it backwards, but it kind of feels that way. So again, we can engage in GSOCs. But if I talk about the JVs, remember we're going from 50s to like 100. So the JV distribution seems somewhat triangular. However, the varsity distribution seems somewhat skewed right because we have this tail towards the right. We go from 70s all the way to like somebody had 113 pulse rate. And so we have this tail towards the right, so that's called skewed right. I don't see any visible outliers or gaps. And then we'll talk about the spread later, either using like standard deviation or IQR. But if we talk a little bit about the center, so the center of these values, whether it be the mean or the median, looks like the JV pulse rate mean or median is going to be lower than the varsity pulse rate mean or median. So it looks like varsity has in general a higher pulse rate, and the spreads kind of look about the same. So the data is spread out about the same, but the shapes are definitely different. So I hope this helped with your basics of a stem and leaf graph.